All right, let's see what we got. For warm-up number 16, it reads, simplify to lowest terms, in parentheses, factor each number first. And they give us for number 1, parts A and B. A reads 4 over 6, or in other words, 4 divided by 6. And for part B, they give us x squared over x squared minus 2x, or in other words, x squared divided by x squared minus 2x. For numbers 2 and 3, it says factor. That's a review of what we did last week. And they give us for number 2 is x squared plus 8x plus 12. For number 3, it's x cubed plus 3x squared plus 3x plus 9. For number 4, it says solve for y, number 1. And then the second part, it says evaluate when the domain is -1, 0, and 1. And number 4 reads -9x plus 3y equals 12. And for number 5, it says add or subtract, and they give us the fractions 8 over 15 plus 5 over 6. All right, so let me go over number 1 just to make sure we understand what it says. It says simplify to lowest terms, and it says factor each number first. So look at number 1a. 4 can be represented which way? What are the factors of 4? 2 times 2, or 1 times 4. I'm not using 1 and 4 because 4, it gives us the same number. So how about 6? What are the factors of 6? 2 times 3. Okay, so now that we have that, now we can simplify. We're going to simplify. Does everybody see the giant 1? Yeah, what is 2 over 2? 1. And what does that leave us with? 2/3. Yeah, now those of you that were with me in the past, this should ring a bell because I had you guys do a lot of these. If it doesn't, maybe you need to drink some orange juice. Why, Tony? Why?
Because it's concentrated.
Bam, let's go. Yes. All right, let's look at part B. Can we factor x squared? Yes, x times x. Okay. What is GCF for the denominator? Yeah, x. And we're left with x minus 2. Okay, do you see the giant 1? Yeah, x over x is a giant 1. So that leaves us with what? X over, and what's in the denominator? X minus 2. And that is already simplified. Simplified. All right, does that kind of ring a bell? Yeah, a little bit. All right, number 2. You should be already able to factor that one. You should have gotten, let's see, x plus 2 and x plus 6. Hands, have you got that? Okay, good. Number 3, you should have been able to group. So GCF here was x squared, and we're left with x plus 3. GCF here is 3, and we're left with x plus 3. So what was the same here and here? It was x plus 3. And what was left over? X squared plus 3. Hands, have you got that? All right, good. Yeah, by now you should be able to do that by yourself. Let me go over number 5. Now, if you notice, I've been easing you into 2 variable equations because we're about to, after we cover the next concept that's coming up, we're about to get into 2 variable equations with graphing, and from there we're going to go to functions. And I'm kind of trying to ease you in with this practice. That's why it's so important that you guys continue practicing on the warm-up, okay? So it says solve for y. I'm going to draw a line down the equal sign. I need to leave y by itself. What's next to it? The negative 9x. So I need to add 9x to each side, add 9x. And we're left with 3y equals 9x plus 12. Am I done? No. Divide by 3, divide by 3. And that leaves us with, on this side, y equals, what's left here? 9x divided by 3 is 3x. 12 divided by 3 is 4. This is solved for y. What did we solve for? Y. Last week we solved for x. Okay? All right. So now it says evaluate when the domain is -1, 0, 1. What does that mean, Mr. Q? Domain. Domain, if you can recall, are all the x values given. So what are the given x values? -1, 0, and 1. And what do we do with those values? We substitute those in the equation to get a y value, which is known as the range. So here it goes. What is the first value I'm going to substitute into the equation? -1. That goes in here. Is it coming back? Yes. So instead of x, I'm going to write what? -1. So what is 3 times -1? -3. And then at the end, plus 4. What is -3 plus 4? 1. Let me do the next one. What's the next number we're going to substitute? 0. Again, we substitute for x. So that leaves us with 3 times 0 plus 4. What is 3 times 0? 0 plus 4. And what do we have left? 4. And last but not least, we're going to substitute the 1 in here. So we're left with 3 times 1 plus 4. What is 3 times 1? 3 plus 4. That is 7. And we just evaluated with a domain -1, 0, 1. Show of hands if you remember that. Is it coming back, kind of? Some of you? Yeah. Yeah, it's coming back, kind of. A good thing in the summer, you actually spend time going through videos and such, getting ready for Algebra 2, huh? Let's go. Mel. No. All right. And last but not least, let's go over add and subtract 8 15s plus 5 6s. 8 15s plus 5 6s. Let me do that by itself. 8 15s plus 5 6s. So in order to add that, we need to find a common denominator, which means we need to rewrite each fraction. And you're saying, how do we do that, Mr. Q? Well, it's very similar to what we did on number 1 with simplifying the fraction. So look at this one. I'm going to rewrite the denominator of this one, of 15. What factors make up 15? 3 times 5. Okay. What factors make up 6? 3 times 2. I'm going to bring down the 8, and I'm going to bring down the 5. Okay. So question, what do each one have in common? They have in common the 3. And what do we call that? We call that the GCF. Okay. But what is it that they don't have in common? What does this denominator need that this one has? Oh, well, this one has a 5, so I need to multiply this side times 5 also. But whatever I do to the denominator, I do to the numerator. What does this denominator need that this one has? Oh, this one has a 2, so I need to multiply times 2. And whatever I do to the denominator, I need to do to the numerator. Therefore, let's see, 2 times 8, that's 16. 2 times 3 is 6, times 5, that's 30. Bring down the plus sign. Let me go to the other side. What is 5 times 5? 25. 3 times 2 is 6 times 5, that's 30. And now we have a common denominator. So this becomes, the denominator stays the same. And we only focus in the numerators. What is 16 plus 25? That is 41. And we'll leave it like that for right now. We can simplify, but I'm going to leave it like that for right now. That's the process that we use. Sometimes we skip all those little steps because we do most of it in our noodle now, but that's the mechanics of the process that we're going to need for what's coming up. Okay. All right, let's move on. Our agenda for today, we did warm up number 16. Today we're covering dividing polynomials, something that we call synthetic division. Our home plate for tonight is pages 331, all only, all only. All right. Your asynchronous code for Nearpod is as follows. Asynchronous code is GALF 7. GALF 7. And once again, guys, some of you are forgetting when you sign in. Remember, if you're in period 4, then you write the number 4 only, and then your first and last name. I don't need to see or read period 4. Just write the number 4, your first and your last name. All right, let's move on. Your previous home play, there's nothing to turn in because you've been turning in stuff, and I said go and catch up with lessons that you need to view again on home play that you need to turn in, whether it's late. I said I was going to give you partial credit, and also to catch up with your asynchronous assignments. All those, you can get the codes from the YouTube channel and all those videos. Yes? Yes, Mr. Q. All right, good. Once again, tonight's home play is page 331, all only, page 331. And once again, guys, reminder, there is tutoring for periods 4, 5, and 6 from 2 to 3 today. It's free. Free. All right. So our objective for today, can divide polynomials. I can divide polynomials. That goes on the bottom left. Can divide polynomials and get a Freire model. Let's see. By now you should know the definition, one example, one non-example, and a hashtag. I'll give you guys 2 minutes. Fill that in without looking at your notes. Go. All right, so here goes a quick recap of where we're at. We started with types of division. I showed you guys the 3 different ways of writing it, and I said we're going to focus on long division. And then we started doing some of these long division examples. And we went to this, we went to this, we went to this. From there, I think I left you this for your asynchronous assignment. This one, this one, this one, this one. And then we did this one in class. Oh, my bad. And this is where we arrived. We're now in example 3, so write this down. Example 3, divide using synthetic division. Synthetic division, and it reads x cubed plus 7x squared plus 16x plus 12. X cubed plus 7x squared plus 16x plus 12. All right, copy that. I'm going to go over it. Just copy it, because synthetic is quite a bit different from what we've been doing with long division. But it's fairly simple once you get the process going. All right. All right, so here we go. I'm going to go over this example, and then you're going to copy. But for right now, just pay attention, please. I don't want you guys to get confused. All right. So here we go. First things first. I'm going to focus using synthetic division. What is that, Mr. Q? That means that we're going to do division without using any variables. Without using any what? Variables. So focus on this one. Look up, please. First thing I want you to notice on the dividend has coefficients. Is that correct? What is the coefficient here? 1, here, 7, here, 16, and here it's a constant, so we'll just use a constant. However, is it in standard form? Let's see. 3, 2, 1, 0. Yes. Are there any powers missing? No. All right, so here we go. Writing utensils down, look up to the screen. Here goes the process. All right, here it goes. 1, 7, 16, 12 divided by -2. Pay attention to this part. Ready? Here goes the process. First things first. Whenever we use synthetic division, I'm going to leave an empty space underneath each number. Then I draw a line. And the very first coefficient, I bring it down all the way down below this line. Why, Mr. Q? Because that's the process of starting with, instead of going from here and starting from here, we bring this down. We're going to start with a process down here. So check, here goes the process. This now became my quotient. I'm going to do that in red. Focus, please. Here it goes. What is -2 times 1? -2. I'm going to write that right above the line, one number over, or one space over. So that is -2. Okay? Look what I'm going to do next. I'm going to combine these. And I get, what is 7 minus 2? 5. All right? And I do the process one more time. What is -2 times 5? And that goes right here. That's -10. Let me combine it again. Focus, please. What is 16 minus 10? 6. I do the process one more time. What is -2 times 6? That goes right there, which is what? -12. Combine these, and that gives me what? 0. I'm going to change the color. Who remembers what color I used for green? That was my what? My remainder. Now, here goes the process one more time before you copy. Look up, please. I write my dividend using coefficients, including the constant. There it is. I use the polynomial given, but notice here, instead of using +2, I used what? -2. It's like if I was solving this equation for x. There it is. I multiply, I bring the first number down, there it is, and I multiply. Each term, I bring it up, combine. So what am I doing here in between? I am combining between these two to get this number. Now hold on, here it goes. What is my quotient? Look up, please. Quotient. This now is 1x squared plus 5x plus 6. And I'm done because there are no leftovers. What? Copy that. Let's go. Woo! Copy that. Go. All right, here goes the process one more time. We're using synthetic division. So how is that, Mr. Q? Well, first we need to check that they're in standard form. They were. And then I use the coefficients of the dividend. Here's 1, 7, 16, and I use the constant. So that I write them out right here without any variables. Then the divisor here, instead of using +2, I use -2. Why, Mr. Q? Well, if I was to ask you to solve for x, to solve for x, we would do x plus 2 equal to 0. How do we solve for x? -2 minus 2, x equals -2. So what are we noticing? That basically we're doing the opposite of whatever we have here. Okay? So we start off with our divisor being -2. Look up, please. So this spot is the third degree, x cubed. This spot is for the x squared. This spot is for the x. And this spot is for the constant. The constant. Because there is no variable here. But as soon as I bring the first one down here, look up, please. As soon as I bring the first one down, it's no longer x cubed. Now it's what? X squared. The very first one's going to be the x squared spot. What spot is this? The x spot. And what is this one? Our constant. Our constant. Does everybody see that? That as soon as it comes down below the line, it changes to a degree less at each spot. And from there, we just multiply, write it up here, combine, multiply, write it up here, combine, multiply, write it up here, and combine, and we're left with 0 remainder. All right, let's do another one together. Let's see how we do. Example 3Q, copy this one. X cubed plus 5x squared minus 17x minus 21 divided by x minus 3. I want you to write me just the setup. Don't do anything else. Write me whatever you're going to use for the dividend and whatever you're going to use for the divisor. See if you get it right. All right, what is the very first thing we check for? Kiana.
Yes.
What is the very first thing we check for?
Positive.
Standard
If
form.
all the exponents.
Yeah, so this is third, second, first, 0. Yes, it's in standard form. How about this one? 1, 0. Yes. All right, let's see if you wrote the following. Who did 1, 5, negative 17, negative 21, and all that divided by 3? Hands, have you got that? Okay, good. Yeah. All right, so leave a space underneath here. And if you want to fill that space so like that, you don't get confused, remember, just use the word combine, because at the end we need to combine with the number we write there. All right, so first things first, we write the first number, we bring it down. Here it is. So what is 3 times 1? 3, and we write it right above the line, but one space over. There it is. And then we combine. What is 5 plus 3? 8. Let's do it again. What is 3 times 8? We write it above the line, one space over, so that is what? 24. Now we combine. What is 24 minus 17? 7, Mr. Q. All right, good. Last but not least, we multiply once again the 3 times 7. That's 21. We write it right above on the next space. Combine. What is 21 minus 21? That is 0. That's our remainder. So therefore, what is our quotient? Quotient. Our quotient is 1x squared plus 8x plus 7. Since we don't have any remainder, we are done. Woo! Let's go. Show me with fingers how comfortable you are with these. Show me with your fingers how comfortable. 5 4s, 5 4s. Yeah, some of you are like, Mr. Q, how come you didn't show us this before? I know, right? Woo!
What would happen if we end up with the remainder?
Very good question. We'll get there. What happened when we did long division? We ended up with a remainder.
We put it on. We put the remainder on top of x minus 3.
Exactly. That we do like
Okay.
plus whatever the remainder is. Good job. Let's move on. So that's example 3Q. Here goes example super Q. Let's see how you do by yourself. Now I did one by yourself. I did one by myself. We did one together. Now let's see how you do by yourself. Ready? Example super Q. It reads x cubed plus 8x squared plus 17x plus 10 divided by x plus 5. Copy that. I'll give you 2 minutes. Ready? Go. All right. Let's see how we did. So step 1, we check for standard form. Let's see, this is 3rd degree, 2nd degree, 1st degree, 0 degree, yes. 1st degree, 0 degree, yes. Then we use the coefficients of each of these of the dividend. So I got 1, 8, 17, and the constant, which is 10. I'm going to divide by, you should have written what? -5. Hands if you set that up like that. Yeah, very good. Now, me, once again, I like writing here to make the space combine. So like that, I remember to combine this way. Once I get a number, I leave a space underneath here and I draw my line across. What is the first number that comes down? The very first term. What is that number? 1. And then we start our process. What is -5 times 1? -5 times 1 is -5. Combine these two, 8 minus 5, that is +3. Do the process one more time. -5 times 3, that's -15. That goes right here. Combine 17 minus 15, that is 2. Do it one more time. -5 times 2, that's -10. It goes right there. Combine those two, and since it's the last one, that means that's my remainder. All right, therefore, my quotient is x squared plus 3x plus 2. Since we don't have any remainders, this is my quotient. Hands up, you got that? All right, good. Yeah. Show me your fingers shall come to your all with these. 1 being the lowest, 5 being the highest. 4, 5, 4, 5. Yeah, I think we got it. Yeah? Okay. So, with that said, the question was, Mr. Q, what happens if blah, 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 blah? Well, let's find out. Copy this one, example 3 mega cube. And it reads 7x cubed minus 6x plus 9 divided by x plus 5. And we're going to do this one together just to make sure we stay with the same process. So everyone, first thing we check for is standard form. That is correct. So let me make some space above. And let's see. Is this, this is third power. This is the first power. This is 0 power. Is it in standard form? Yes. But is it missing a power? Yes, it's missing the what? The 2. Box that because we're going to need to fill in for that spot. Let's go to the next one. First degree, 0 degree. Okay. So here we go. Let's write our dividend using synthetic division. What goes first? 7. What would go next?
You used to put 0. Would it go 0?
Exactly. Or... we use 0 because we need to allot for the spot of the second degree. What is the next coefficient? -6. And the last coefficient or the constant, 9. And we're going to divide by, what do we divide by, everyone? -5. All right. Before I moved on, if we were to be in class, I would say, turn to your neighbor and let them know where we got that 0 from. Where we got that 0 from. Or if there's anybody there at your house, tell them where you got that 0 from. Your pillow or your pets. Oh, okay. Yeah, so here it goes. Coefficient 7 is right here. Since we're missing the second power here, in here, we would have written plus 0x squared for that spot. That's why we wrote 0, then -6, then 9. All right, so I'm going to write combine. Leave an empty space. Draw my line across. And what is the first number that goes down? 7. All right, so what is -5 times 7? -5 times 7, that's -35. Goes up here. All right, combine. We bring down the -35. Let's multiply again. -5 times -35, that's positive 175. Combine. 175 minus 6, that's 169. And lastly, we're going to multiply the negative 5 times 169. That goes up here. That's negative 845. Since this is the last one, this will be our remainder. Let's see. What is negative 845 plus 9? That's negative 8. Let me rewrite this. There it is. Negative 836. You're like, Mr. Q, now we have a remainder. Of course we have a remainder. So let's find our quotient. Our quotient. What's our quotient? 7x squared. What else? Minus 35x. What else? Plus 169. But now that we have a remainder, what do? Who remembers? Hands? Yeah, we put plus a fraction bar, and our remainder is negative 836. And what's our divisor? X plus 5. Woo, let's go. Let's go. So my parents, how come you are with these? Where are we at? 5 4, 5 4, 5 4. Yeah, you're saying it's the same thing, Mr. Q. I know. It's just a different approach to division. Now we're using, this is what we call synthetic division. Mr. Q, why are we doing this? Because later on, guys, in the course, we're going to get into something called matrices. I might have mentioned this when you guys were in 8th grade with me. I said, have you guys seen the movie The Matrix? And I said, we're actually going to use some of the stuff that was in the Matrix. Those are matrices, and this is kind of like where we're headed in regards to using polynomials, but without any variables. So, all right. So we go with that, but we get to these next ones. Look up, please. Here we go. All right. So you can do that one on your own. I want to get to this one. Example 4. Copy that. You don't have to copy the verbatim. I mean, if you want to, that's fine. But just to save time, just copy the polynomial given and the divisor. And it reads, determine whether the given binomial is a factor of the polynomial p of x. If so, find the remaining factors for p of x. I'm going to repeat that again. Example 4. Determine whether the given binomial is a factor of a polynomial p of x. If so, find the remaining factors of p of x. Okay. So what they're asking for is to see if this is an actual factor of this. Well, how do we know? Well, we can use long division. So here we go. First things first, what do? Check for standard form. Don't worry about the p of x. This is just saying that this is a polynomial of x. What is the degree of this one? 4. What is the degree of this one? 3. This one, 2. This one, 1. And this one, 0. Okay. How about this one? 1 and 0. Yes, they're both in standard form. So what would I write for this, guys? What are my coefficients? This is 1, this one, negative 4, this one, negative 6, this one, 4, and this one, 5. And we're going to divide by what? What do we divide by? Yeah, negative 1. Who thought that? Yeah, it's the same thing that we did, but now they use a different way of approaching it, and I'll show you at the end what they do. So I'm going to write underneath, once again, combine. So like that, I don't forget to combine. I leave the space underneath the word combine, and I bring down the first term, which is 1. And I start my process. Here we go. Negative 1 times 1 is negative 1. Combine, that's negative 5. Do it again. Negative 1 times negative 5. Bring that up here. That's 5. Combine, what is negative 6 plus 5? Negative 1. Let me do that again. Negative 1 times negative 1. That goes right here, which is 1. What is 4 plus 1? That is 5, because I'm combining. And the last one, -1 times 5, that's -5. Combine, and that leaves us with what? 0. That's my remainder. So I'm going to write my quotient. 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 Okay? So what's my quotient? Look up, guys, or you're going to miss it. We started with to the 4th power. So when we brought it down, this becomes what? To the 3rd power, x cubed minus 5x squared minus 1x plus 5. Does that make sense? Yes? Okay. However, whenever we end up with a 0 remainder, pay attention to this one. Whenever we end up with a 0 remainder, this is, yes, it's a factor. Because remember the instructions. What did the instructions say? Determine whether the given binomial, this binomial, is a factor of the polynomial. So whenever you end up with 0 remainder, that means it is a factor. But look at the second part. If so, find the remaining factors for P of X. Look at the remaining. Look up, guys. Look at the quotient. How can I factor this? Don't say it out loud. Think about it. It's a polynomial with 4 terms. How can I factor that? Let's go. Who said group? Yeah, group 2 at a time. That is correct. So we group these 2 and we group these 2. GCF here is x squared. We're left with x minus 5 plus GCF for these 2 is -1, and we're left with x minus 5. So what's my factor here and here? What are the same? X minus 5. And what's left over? X squared minus 1. So I write x squared minus 1. And then don't forget to bring down the other factor. Look up. Which is x plus 1. These are my factors. So what is the only thing that we're doing extra, guys? The only thing that we're doing extra is that if we end up with remainder 0, then that means this is a factor, and we need to factor the last quotient one more time to see what we get. All right? Now, up to right there, show me with your fingers how come you are with these. 5s, 4s, 5, 4s. Okay, yeah. So now, for those of you that saw this, look up. Can we factor more this red one right here? Look up this one. Yeah, that becomes what? X plus 1, x minus 1 if I wanted to factor it more or factor it completely, because it's difference of squares. This is that plus these 2. All right? And I'm pretty sure you're in your noodle, you're saying, Mr. Q, but what if you get a remainder? So let me ask you, if we have 0 remainder, then this is a factor. So what if we get a remainder being other than 0? What would you say? That this is not a factor. That is correct. So let's see. Last one, copy this one. Example 4Q. 4x cubed plus 3x squared plus 2x plus 1. And they gave us the binomial x plus 2. We're going to do this one together. What is the first thing we check for? Standard form, let's see. 3rd degree, 2nd degree, 1st degree, 0 degree. Yes. How about this one? 1st degree, 0 degree. Yes. So tell me what to write for my synthetic division. Go Rosa. What do I write?
-2. Oh, wait.
No, that's fine. That's fine. -2.
Divided by 1.
Close. This one has the coefficient of what?
4,
4. And this one?
3,
Uh-huh.
2,
Uh-huh.
then 1.
And 1. That is correct. Thank you. Combine. Leave a space. All right. So let me bring this down. 4. And let's start our process. -2 times 4, that's -8. Combine, that leaves us with -5. -2 times -5, that's +10. Combine, that is 12. -2 times 12, that's -24. Combine, that's -23, Michael Jordan. That's our remainder. Question. Is x plus 2 a factor? Is x plus 2 a factor of this polynomial, guys? Chloe, what do you think? I can't hear you. Still can't hear you.
No.
No, not a factor. Why not? Because we got a remainder other than 0. Anytime we get a remainder other than 0, not a factor. So that means we are done. We don't have to do anything else. However, if it's 0, what would you have to do? You needed to write your quotient. And by the way, what would be our quotient here, guys? 4x squared minus 5x plus 12. And then we would do the process for factoring if this was 0. Quotient. And then since this one has a remainder, we would write what? Plus -23 over x plus 2. All right. But like I said, that is if you were to get 0 here, you would do the factoring, continuing the factoring right now. I just wrote the quotient because we can't do anything else. All right, guys. Well, that's the home play. Pretty much that's all you're going to have for tonight on page 331. You're going to be having some using synthetic division and a couple of them that look like this. Once again, reminder, we have tutoring from 2 to 3. So make sure if you have that time in your hands that you want to join us, we'll be available. All right, guys? So once again, don't fall behind. Keep at it with your home play. Nice seeing you guys. Have a good one. See you guys to Wednesday. Peace.